Hello everyone, and thank you for listening our presentation today. Our project is titled Prompt Shield, a RAG agent framework for secure code generation via prompt rewriting. In recent years, large language models or LLMs have become incredibly powerful tools for code generation. But as much as they make programming faster, they also bring a new problem. They often generate insecure code. Our project focuses on how to make this code generation process safer, not by retraining the model or modifying its structure, but by improving the prompts that users provide. Throughout this talk, I will explain the motivation behind our idea and how the system works and the challenges we faced and what we learned through this research. And here's the outline for today's presentation. I will start with the introduction and motivation, where I will explain why prompt security is real and growing concern. Then I'll move on to the related work, showing what previous research has done and where the gap lies. After that, I will introduce the prompt shield framework, explaining how our red and blue agents collaborate using RAG-based system. Then I will discuss what we expect from the system, its limitations and challenges we encountered, along with how we try to overcome them. And finally, I will wrap up with the conclusion and share some key takeaways for future works. Then let's begin with a simple question. Can we really trust the code that LLM generate? Over the past few years, models like GPT, CodeGen, and StarCoder have shown impressive skill in writing code across multiple programming languages. But they also have a tendency to produce insecure outputs, especially when the prompt given by the user is vague or underspecified. For example, an LLM might skip input validation or store user passwords in plain text or use unsafe APIs without realizing the consequences. Existing mitigation strategies have tried to fix this problem in different ways. Some researchers fine-tune models using secure code dataset, while others apply post-hoc vulnerability filtering after generation. But these methods are often expensive, slow, and not flexible. They depend on modifying the model itself or retraining it every time new vulnerabilities appear. So our idea is a bit different. Instead of changing the model, we focus on changing the prompts, automatically rewriting unsafe prompts before the LLM even starts coding. This is where Prompt Shield comes in, a proactive framework that strengthens code security at the prompt level. Before explaining our system, let's look at what previous work has done. First, in the area of secure output generation models, researchers have proposed methods like prompt tuning or fine-tuning to make code outputs more secure. However, all these methods focuses on training the model, not on the prompts that trigger its behavior. And second, prompt engineering tries to improve output quality by embedding security constraints directly inside prompts. This can help prevent unsafe outputs, but it's usually manual and inconsistent and hard to automate across different users. And finally, we have red-blue teaming approaches. These simulate attack and defense scenarios to find vulnerability in LLMs, but they mostly focus on evaluation, not defense. They tell us what went wrong, but now how to fix it automatically. So, to summarize, most existing approaches are model-centric or evaluation-centric. In contrast, our approach, the prompt shield, is prompt-centric. We introduce automation and adaptivity at the prompt rewriting level, forming a new layer of proactive defense. So what motivated us to design Prompt Shield? Let's start with the problem. LLMs tend to produce insecure code when the user's prompt doesn't specify security requirements clearly. For example, if you just say write a user registration API, the model might store passwords in plain text or skip validation altogether. Next, we found that existing solutions don't scale well. Model fine-tuning is expensive and requires massive resources. And also, red teaming helps us find vulnerabilities, but it doesn't fix them. And, and next, the manual prompt crafting depends on individual skill, so it is not consistent. After, we also noticed that the same types of vulnerabilities keep showing up. Missing input validation, unsafe API calls, or storing sensitive data insecurely. So we asked ourselves, what if we could automatically rewrite user prompts in a secure way while keeping their original intent? That question becomes the foundation of our project. To overcome these challenges, we propose Prompt Shield or RAG agent framework for secure code generation via prompt rewriting. Our key idea is to make the system adaptive using RAG-based knowledge retrieval and collaboration between two agents, one acting as an attacker and other as a defender. Let me now walk you through the how system actually works. Prompt Shield consists of two main components, the red agent and blue agent, both supported by the shared RAG knowledge base, and an evaluation module. The red agent, or attacker, tries to break the system. It generates adversarial prompts that intentionally guide the LLM toward producing vulnerable code. To do this effectively, it retrieves examples from RAG, such as known CWE patterns, vulnerability reports, or previous attack templates, and mutates them to test the model's weakness. Every time the red agent performs an attack, it records everything: the adversarial prompt, the LLM's output, and which vulnerabilities were detected, and stores them back into RAG for the future learning. Then comes the blue agent or defender. It takes the red agent's adversarial prompts and rewrites them to ensure the resulting code is secure, while still preserving the same functionality. The blue agent queries RAG as well, but it looks for defensive guidance documents like on OWSP or NIST or secure coding templates. Finally, the evaluator plays a central role. It tests both the functional correctness and security quality of the generated code. For functionality, we run unit tests, and for security, we use code query static analysis to detect vulnerabilities. All this feedback, both success and failure, is written back into RAG. Over time, this continuous loop makes both agents smarter. The attacker learns to generate stronger attacks, and the defender learns to produce stronger defenses. In short, Prompt Shield becomes a self-improving ecosystem for secure prompt rewriting. And from this framework, we had a few key expectations and of course some limitations. On the positive side, we expect to identify which prompt patterns lead to insecure code and which makes the model generate secure outputs. This gives us empirical insights into how prompt phrasing affects security outcomes. Rewriting through the blue agent greatly reduces vulnerabilities such as unsafe API calls or missing input validation, and while keeping the intended function unchanged. Also, because RAG keeps updating based on results, both agents gradually becoming better, meaning the systems get smarter the more it runs. However, we also notices some limitations. Sometimes, security rewriting can make the code less functional or too strict, illustrating usability for safety. And the LLM may also refuse attacker-style prompts, which affects how reproducible the red agent's attack can be. And of course, if our RAG database becomes biased or outdated, both agents might learn incorrect lessons. To address those problems, we designed several mitigation strategies, and I will explain those mitigation strategies in the next slides. Implementing this system was not easy, and we faced four main challenges. The first challenge is prompt rewriting accuracy. It's not easy to rewrite prompts that remove vulnerabilities while keeping the original logic intact. Our solution was to use RAG to expand the rewriting context, so that the Blue agent always has access to relevant security examples when modifying a prompt. The second challenge is performance overhead. Because each prompt undergoes attack, defense, and evaluation, the whole process can become slow. To solve this, we built a more efficient rewriting algorithm, reducing the unnecessary checks. The third challenge is LLM unpredictability. As many of you know, even the same prompt can sometimes produce different outputs. To make your results stable, we rely on agent-based coordination and average multiple outcomes. So the framework learns consistent rewriting behavior. And finally, the fourth challenge is limited security knowledge. RAG doesn't contain all vulnerabilities at first. To improve this, we continuously updated it with every new attack and defense case. In the end, our approach aims to balance security, functionality, and efficiency, creating a reliable workflow for secure code generation. And to wrap up, let's summarize what we have talked about Prompt Shield. First, we are willing to introduce an adaptive dual agent framework that enhances LLM code security through automatic prompt rewriting. And second, the attacker-defender interaction allows us to discover which prompts are vulnerable and which are secure, providing a systematic way to study prompt security relationships. Third, the continuous RAG improvement enables self-learning, where the system gets better over time by learning from both successful and failed examples. And finally, the prompt shield is lightweight and practical. It strengthens LLM-based code generation without retraining or modifying the model. In short, our goal was to defend LLMs not by changing how they think, but by changing how we talk to them. And it is the end of our presentation. So thank you very much for listening to our presentation. And we would happy to answer if you have any questions about this project.